Welcome to my top 10 Firebase tips. Welcome to my top 25 Firebase tips. Nope, welcome to my top 100 Firebase tips. I've been working with Firebase for several years now. I've made plenty of mistakes along the way, but I've also uncovered some secrets that you may not know about. So hopefully this video makes your experience with Firebase 100 times easier. If you're new here, like and subscribe, and if you're serious about building an app with Firebase, consider becoming a pro member at Fireship.io. You'll get access to full project courses and a free t-shirt if you sign up for life. Or you can get a free t-shirt by leaving the best Firebase tip in the comments below. The first thing you'll need is a Firebase project. If you're building a serious app, create two Firebase projects, one for development and one for production. This gives you a sandbox for testing and experimenting, and you can keep your customer data pristine in the production project. In your production project, link Google Analytics. Firebase can automatically set up analytics for iOS, Android, and the web. If you're working with a team, head over to the Settings tab and then go to Users and Permissions. Assign roles based on the principle of least privilege, so team members only have access to the resources that they actually need. From there, head over to the Data Privacy tab and update your contact information to ensure you're in compliance with GDPR. Now click the button to add a new app to your Firebase project. When you do that, it will give you an object with a bunch of credentials. Don't worry, these are perfectly safe in your front-end code as long as you set up security rules, which we'll look at later. Upgrade your Firebase plan to Blaze. It's pay as you go, but you still get all of the free stuff that you would on the Spark tier. But you still want to stay on top of cost, so head over to the GCP console and set up a budget alert for your project. Then monitor your monthly usage from the reports panel. This will tell you exactly which services are costing you the most money. Make sure to install the Firebase command line tools globally on your system, and also the Google Cloud SDK. A Firebase project is actually just a layer on top of a Google Cloud Platform project. Once you've done this, you should have access to the Firebase command and the gcloud command on your local system. So now that we have a project set up, let's look at how we can actually deploy our code to this project. If you're building an iOS or Android app, use Firebase App Distribution to distribute your app to testers. This will bypass TestFlight and the Google Play Store, making your life much easier. Now, if you're building a web application, you're likely using a package manager like NPM. Install Firebase tools into the development environment for that project. And now you can write NPM scripts that use the Firebase CLI tools. Now, if you followed my earlier advice to set up different projects for development and production, you can use the project flag to set up different commands that specify the project. So here we have a command to deploy to our development project and another for our production project. Now, after you've deployed your site, head over to the Firebase console, and you can see it's deployed at a cool domain called yourproject.web.app, or you can just connect your own custom domain. And you're not limited to a single domain. For example, you might have an admin site and a customer-facing site. They can both share the same Firebase project with multi-site hosting. Then go into your Firebase JSON file, change the hosting value to an array, and set up different targets that represent the different sites you want to deploy. Now, you're not just limited to static files when deploying to hosting. You can actually rewrite traffic to a Cloud Function or to a Cloud Run instance. And that means you can do SSR with something like Angular Universal or Next.js. You can also set up Firebase hosting rewrites for dynamic links. This allows you to dynamically send the user to the app with the best possible experience. So if the user goes to a link on their iPhone, it will take them to a specific screen in the iPhone app. You can also specify headers on the static files in your hosting account. For example, if we wanted to change the CORS settings for all of the font files, we could do it like this. And Firebase hosting will also cache our static files for better performance, but we can change the caching behavior by setting different cache headers here as well. And one cool thing you might do to extend Firebase hosting is to set it up with Google Cloud Build. So every Git commit you make to your project, it will deploy a new version of your site to your hosting account. That's exactly what I do for Fireship.io. Firebase provides two different fully managed NoSQL databases, so how do you know which one to choose? I default to Cloud Firestore because it has more powerful query capabilities. It also costs less per gigabyte stored. However, real-time database does not charge for writes, so it can be a great option if you have data that's updated frequently, like an IoT sensor or something along those lines. But when it comes to pricing, you really shouldn't worry about it too much.
Don't even trip, dog.
Firebase overall is very inexpensive, and it will take a decent number of monthly active users before you even break out of the free tier. Unless you make a silly mistake, you'll be paying much less than you would be with other cloud solutions. A more important thing to worry about is that you back up your data on a regular basis. Set up a dedicated cloud storage bucket for backups, and then you can back up your entire database with a single command. When you create your database for the first time, set it in locked mode. It's safer to start with a lockdown database than incrementally allow operations as they become necessary. After you've created a Firestore collection, go ahead and click the filter icon, and you'll see that you can make queries directly from the Firebase console. And it even provides some code for your query that you can copy and paste to use in your app source code. In fact, let's go ahead and switch gears and jump into the source code for a JavaScript application. Now, the way you import Firebase depends on the flavor of JavaScript that you're using. You can see the import syntax here for CommonJS, ES6, and TypeScript. But all of these are actually wrong because they're importing from Firebase directly. Your code will work, but it will create a huge JavaScript bundle that will slow down your app. The correct way to use Firebase is to import from the Firebase app namespace and then import the services that you plan on using, aka progressive enhancement. In any case, Firebase is a pretty big dependency, so if you're loading it with a script tag, you'll want to use the defer keyword on that script to ensure it loads after the actual DOM or HTML has been parsed. But if you're using a framework, then you shouldn't have to worry about this. Angular apps should use Angular Fire, which integrates with change detection and the Angular router. If you use React on the front end, the React Fire library was just undeprecated, and it provides support for hooks and suspense. You have RxFire to integrate with RxJS, which works great in frameworks like Svelte. Then outside of the web, you have support for all kinds of different other frameworks in Firebase Extended like Flutter, Arduino, and many others. When you first add Firebase to a project, there's a couple of no-brainer services that you'll definitely want to use, such as performance monitoring. With a single line of code, we can see how well our app performs out in the wild, giving us metrics like first contentful paint across all devices using our app. The next one is Crashlytics, which is only relevant to native mobile apps. It's very easy to set up, and it will give you error reporting and crash reporting throughout your entire application and automatically open issues so you can address those problems. And lastly, we have Firebase Analytics. With a single line of code, we'll get the default reporting from Google Analytics, giving us insight about the behavior of our users. Now, in your source code, one of the first things you'll likely want to do is determine if a user is logged in or not. There are two main ways to do this. You can pull the current user at any time by calling auth current user. This is usually best for handling events, like when the user clicks a button and then you want to grab their auth record and do something afterwards. The other way to get the current user is to always be listening to the current auth state. In this case, you provide a callback function to listen to changes to the auth state, like when the user signs in or signs out. In either case, I recommend getting good at asynchronous JavaScript to be successful with Firebase. Understanding async await is very useful for the first approach, then understanding callbacks and functional programming is very useful for the second approach. When a user attempts to log in, something might go wrong. It might be your fault as the developer or the user's fault. In any case, you'll want to make sure that you catch these errors and then create a default handler that routes them to a visual UI element like a dialog. A cool trick you can do with Firebase Auth is to register a user lazily. For example, you might first have a user sign in anonymously, which will give you a user ID that you can tie to the database. Then later in the onboarding process, you can collect their email or link social accounts like Twitter, Facebook, Google, etc. Now, certain authentication methods like email password may need to send emails to your users for things like email verification and resetting passwords. Sometimes you might want to control this process on your own, which you can do with custom email action handlers. And you can even bring your own custom SMTP email server. Now, one of the most important aspects of any application is managing relational data. Let's check out a few common techniques for connecting our users to the Firestore database. We can create a one-to-one relationship where the user has one document in Firestore by first retrieving their user ID, then we'll make a reference to a collection and set the document ID as the user ID. Every user ID is unique, so it guarantees that that user can only have one document in that collection. Now, if it's possible that data already exists there, you might want to use the merge true option. This will ensure that any data that already exists there won't be overridden. The merge true option just makes it a non-destructive update. Another common relationship is one-to-many. A user might have many orders, but an order belongs to one user. The best way to handle this type of relationship is to use a sub-collection. In the last example, we created a document with a user ID, and we know that every sub-collection under that document is owned by that user. But sometimes you might run into a situation where you want to query orders across all the users in your database. Firebase provides a special method that allows you to group sub-collections and query them together. Collection group will find all of the collections that share the name orders, group them together, allowing you to make a single query against all of them. Then another very common relationship is many-to-many. In this case, we have a single collection called chats, and each chat document can be associated with multiple users. We can associate multiple users to multiple chats by embedding their user IDs on the chat document using a map of key value pairs. The key is the user ID, and then I'm going to duplicate the display name in case we want to show that in the UI. Data duplication is perfectly okay in NoSQL. It can optimize for performance and costs, but it works best with values that are immutable or that don't need to be updated very often. And now that we have a map object on this document where each key in that map is a user ID, we can query it by using dot notation in our queries, like order by members.userid. Now that we've modeled some data and made some queries, we need to decide if we want our data in real-time format or not. If you're trying to optimize pricing and don't think you'll need real-time updates for your data, you can just call query get to retrieve the data once and then not listen to any future updates. But if you are building a feature where the UI should react to changes in real time, you'll want to use query on snapshot, then run a callback function anytime the underlying data changes. On a collection query, when you listen to docs, you'll get a new array anytime there's a change to the underlying data. But you might want to know exactly which documents were added, modified, or removed. Doc changes provides an array of all the documents that changed, their old index, new index, and the change type. Another awesome thing about Firestore is that it's able to work offline. If the internet goes out and the user's still trying to send writes to the database, Firestore will still update the UI and then send those writes to the actual database and commit them after the internet comes back online. And you can even make this work across multiple browser tabs by setting the Synchronize Tabs option to true. Now, one question I get a lot is how do I use emoji characters in my code? Well, they're actually just UTF-8 characters, which means you can use them in a regular string. And that also means that you can use them in your Firestore documents and make queries against them. Another trick you might want to use is to match a wildcard string. For example, if we wanted to query all of the Fast and the Furious movie titles. Create a starting point and then make your ending point a tilde character. This will match all of the documents that start with the Fast and the Furious title. And with that, we have reached the halfway mark. Let's take a quick break. Welcome back. Sometimes you might have a compound query, where you chain together multiple query conditions. This query won't work by default because it requires an index. But don't create the index manually. Let your app throw an error, then click the link to the Firestore console to create the index automatically. One of the most powerful data types in Firestore is a list. We can add a list to a document by simply setting it with a JavaScript array. But we might decide later that any good Firebase recipe needs to include a pineapple. We can use the Firestore array union method to ensure that the array includes exactly one pineapple. Or we might decide later on that maybe squid wasn't such a good idea in this recipe, so we can remove it by using the array remove method without having to know the actual index. And now that we have an array on the document, we can query it by using the array contains operator inside of where. And that will give us all of the recipes that contain avocado. Now, sometimes you might have an array that contains IDs of other documents in the database, but how do you actually fetch the full documents in this array? Do it in JavaScript by mapping all of the ID strings to an array of promises that get the document, then run them together with promise.all. One thing you should generally avoid doing is setting a timestamp from your front-end code, because the user's clock might not be synchronized properly. If you need to set a timestamp on a document, use the Firestore server timestamp. That ensures that all users are sharing the same clock. Another thing you might want to do is increment a counter, like the score of the game. You can change the value of the counter atomically without knowing its current value by using the increment field value. Now, Firestore only supports one write per document per second, although you can burst above that value. So if you have a ton of writes happening on a single document, you can set up a distributed counter, which is now very easy to do because there is a Firebase extension that supports it. And speaking of atomic, sometimes you might have writes that need to succeed or fail together. Maybe the user completes the game, you write the score, and then you want to update the user's lifetime score. You can ensure that these operations happen together by setting up a batch write. This will commit them together, but roll back to the previous state if any of the writes fail. Now, Firestore is a great solution for the vast majority of use cases, but sometimes you might need a full relational database. If you need a full relational database, check out my video on integrating MySQL into a Firebase project. Or if you need full text search, check out my Algolia integration video. Now, one of the most important things to do as a Firebase developer is set rules before you deploy to production. If you deploy an app without good security rules in place, your customers' data could be compromised and someone could make destructive writes to your database. Currently, our database is in locked mode, which means we're safe, but now let's go ahead and open up some operations for our users. The first thing you should do is get used to using the simulator. It allows you to pass mock requests to the database to see how the rules will be evaluated. But serious production apps should use the Firestore emulator. This allows you to simulate the Firestore database in your local development environment, so you can throw a whole bunch of different test cases at your rules to ensure that they're robust. Know that there are 5 different types of operations a user can make on a document. They can get a single document, a query of a list of documents, and they can create, update, and delete documents. You can provide fine-grained rules for each operation, or you can combine them by using the read or write keywords. If they share the same logic, just separate them with a comma. When a rule is evaluated, there are 2 things that you'll look at: the request and the resource. The request contains the user's authentication state as well as the incoming data that they're trying to write to the database. The resource, on the other hand, is the data that already exists at this path in the database. But in some cases, you might need to look elsewhere in the database to determine if a rule should be allowed. Use the get keyword and then point to a path in the database, and you can use $parentheses to interpolate values like the request auth user ID. This gives you the value from this document, but keep in mind that you're charged a read every time this rule is evaluated. Now you might notice that this is a very long line of code, and if we were using this frequently throughout the rules, we wouldn't want to have to repeat it all the time. We can extract this logic into its own function called isAdmin, and now we have a much cleaner way to check for admin users. Now let's switch gears to cloud storage. A storage bucket is where you would put things like images, videos, and raw files. You have a default bucket, which is where you would normally save your user-generated content, but you can create additional buckets as well. You might want an additional bucket for Firestore backups, which you can set to cold line, which will save you some money. Now, when you upload a file to a storage bucket, there is a storage location and a download URL. If the user needs to access this file again in the future, I recommend saving both values to the Firestore database. You can use the storage location to replace or delete the file in the future, or the download URL to access the file in your app. But don't worry too much if you forgot to save the file path in the database, because you can use the storage ref from URL and point to either the full path in the storage bucket or to the download URL to access that file. Sometimes you might want to list out all of the files in a directory in the bucket. Simply make a reference to the path to the directory, and then use the list all method to get all of the files at that location. You can upload a file by simply making a reference to a file path, and then putting the raw file that you want to upload. You can calculate the progress of an upload by listening to the state changed event, then divide the bytes transferred by the total bytes in the file. If you have multiple files to upload, feel free to upload them all at the same time. Firebase will automatically handle concurrency and upload them as efficiently as possible. When you upload files, you might also want to save your own custom metadata about that file. You might want to know what kind of device the user uploaded the file from, their user ID, and stuff like that. If your users can upload image files, there's a good chance that you'll want to resize them to different resolutions for different devices. You can now do that with a click of a button using the Firebase Image Resizer extension. At this point, we've been mostly looking at front-end code, so now I want to switch gears to the back-end. You can create your own command line utility for Firebase with 3 easy steps. Go to your project settings and download the service account for your project. In a Node project, install Firebase admin as a development dependency. Then create a JS file that imports it and calls initialize app. Firebase admin needs your service account, but it contains sensitive information. The safest way to use it locally is to keep it somewhere private on your system and then use an environment variable called Google Application Credentials. But if you include the service account directly in your source code, make sure it's in your gitignore so it doesn't end up in a public repo somewhere. One of my favorite things to do with an admin script is to seed the database with some dummy data. Install Faker.js and then import it into your JavaScript file. Then create a loop, and for each iteration, add a new document to the collection using Faker to automatically generate the dummy data. Now run the script from the command line with Node. You should now see a bunch of dummy documents seeded in your database. Now you can do a lot with the Firebase Admin SDK, but you can do even more with the REST APIs. Check out the REST API documentation to find secret techniques that you didn't know about. Earlier I showed you how to back up Firestore from the command line, but you could also do it with the REST API. This would allow you to set up a cron job to back up your database on a daily basis. If you do use the REST API, you'll want to use the Google API's NPM package. This allows you to discover and interact with hundreds of different Google APIs, like AdWords, YouTube, and of course Firebase. Creating an admin script can be useful, but in most cases you'll be working with Firebase admin in a cloud function. You can add cloud functions to your project by running Firebase init functions. When you do this, I highly recommend using TypeScript because it does all the setup for you and will help you catch silly errors before they end up in production. There's a few things we can do to improve the performance of a cold start on a cloud function, and also reduce the CPU time that we're actually billed for. Try to minimize the number of dependencies that you use in your functions. More code to load and parse means a slower cold start time. If you have values that can be shared between multiple function invocations, you can set them up as global variables. When a function instance spins up in the cloud, it might be used multiple times, so global variables can be used across multiple calls, improving performance. When you design your Cloud Functions, they should always be idempotent. Cloud Functions are guaranteed to be invoked at least once, but they can be retried multiple times, so you want to make sure that multiple calls to the same function produces the same result. And you can use the context event ID to help you achieve that. If you need to add more horsepower to a function, you can use runWith to max out the memory at 2 GB and the timeout seconds to 540. Now, one thing you want to be really careful not to do is to create an infinite loop. You might accidentally do this in Firestore by updating the same document that triggered the event. In this example, we have an onWrite function that updates the same document that triggered the write. So this will cause an infinite loop that will charge up your Firebase bill until you hit the quota limits. It's not a good thing to do. However, there are use cases when you might want the triggering function to update the same document. You can avoid the infinite loop by checking if the after document is equal to the before document. This will check for equality on the document path and its data, and that will stop the loop, assuming your function is idempotent. Background Cloud Functions must always return a promise. You can ensure that always happens by using the async keyword in the function callback. Then you can use the await keyword for much cleaner synchronous looking code. Sometimes you might need a Cloud Function that communicates with other Cloud Functions or other GCP services. You could use an HTTP function to handle that, but you would also need to implement some code to validate the request. A better alternative would be to set up a pub/sub function. It allows you to pass messages between your internal services, and that's easier and more secure than exposing an HTTP endpoint. You might also have endpoints that should only be accessed by authenticated users. In a regular HTTP function, you would need to extract the authorization header that you set in your front-end code and then verify the ID token. As an alternative, you can simplify both your back-end and front-end code by using callable functions. It includes the auth context for the user, so you don't have to implement your own middleware to authenticate your functions. A great use case is to delete an entire Firestore collection, which should always be done on the back end because there might be tons of documents in a collection. We can first authorize the operation by looking at the user ID. Then we'll create a recursive function called batch delete. It retrieves documents in batches of 100 and then deletes them. This will ensure that we don't hit memory issues if we try to query millions of documents in a single go. Now, when implementing the actual logic for your backend code, consider breaking it down into small JavaScript functions. This allows you to reuse code across multiple deployed Cloud Functions, and it's also just easier to test. Keep in mind that Cloud Functions provide a gateway to interact with other third-party APIs. Almost every good API also has a good Node.js library to go with it, so basically anything you can build in Node.js, you can build in a Cloud Function. When you're ready to go live, you can deploy all of your functions from the command line with a single command. But on larger projects with dozens of functions, you may not want to deploy everything all at once. You can append the name of the function to the end of this command to deploy a single function. Despite your best efforts, your functions will very likely have some bugs. The best way to prevent bugs is to run the Cloud Functions shell locally. You can invoke your functions with mock data to test their behavior, and Firebase even provides a unit testing library. Now, your functions still might break in production, so you can always look at the Firebase logs to see what's going wrong. Or better yet, head over to Stackdriver, where you can create your own custom dashboards and alerts for the things that you care about. Earlier in the video, we set up analytics in our front-end code. But to get the most out of it, we'll want to track custom events and user properties. Try to pinpoint the events or user behaviors that you think are most important to turning that user into a paying customer. Then use Firebase Analytics to record those events. Firebase will aggregate some of the data automatically, but you can create your own audiences based on the type of user that you want to target. Your marketing team will love audiences because you can target messaging to a specific type of user and also do things like A/B testing and funnels. And as a developer, you can actually use audiences to customize the UI based on your underlying analytics data. The service will send key value pairs down to your front-end application, which you can use to conditionally show UI based on where that user is located, what audience they belong to, and so on. You can also use the same data to send push notifications to your users using Firebase Cloud Messaging. Instead of sending a bulk notification out to all of your users, segment it to the users who actually want it and will benefit from it. And with that, we have finally reached Firebase tip number 100. Leverage machine learning within your app. You can do this in multiple ways with Firebase. Use predictions to guess when a user is going to buy your product. Use MLKit to implement AI-driven features out of the box, things like object detection and smart reply, or build your own image classification models with AutoML. And you can even export all of your analytics and Firestore data to BigQuery and use that raw data to train your own TensorFlow models from scratch. And that is all of the Firebase tips that exist in the world. If you have your own additional tips, leave them in the comments below, and I'll pick a couple of the best ones to win a t-shirt later this week. I'm gonna go ahead and wrap things up there. Hopefully you found something useful in here. Thanks for watching, and I will talk to you soon.